The new all-purpose ink man has arrived with all your favorite catchphrases like
It's time for game plans!
and capable of doing anything you need.
Alright, let's go down now to 8.51, finding the maximum error of the estimate. Number 1, the data from a used sample can be used to make inferences about the corresponding population. This is called inferential statistics. The sample statistics is calculated and used to estimate the population mean, right? Whatever candy comes out, it can tell us what's actually in the machine. We're making an inference or a conclusion about what's inside the machine. There is variation between the samples of the sample population, right? What was coming out of the candy machine. However, which means that the sample statistics will often not be equal to the corresponding population parameter. Like, right, they said half were going to be orange, and was it always half? No, the answer is no. And this is called a sampling error. Sampling error is due to randomness, and it does not include bias or other errors that may occur when obtaining the sample. And as the sample size increases, the size of the sampling error will decrease because the sample increasingly represents the larger population. The standard error, I'm trying to find dark colors. The standard error of the mean, which is sigma and then below is an x, is equal to sigma, so the tail, over the square root of n. So let's make sure we understand that part. This is the population standard deviation. And the n there this is the sample size. And if we need it, that's fine. So we just filled it out there. I did in purple. So we said that where sigma is the standard deviation, we don't have it in there, but x bar is the sample mean, and the sample size is n. Continue on. A confidence interval is an estimate of the population parameter using a sample statistic, stated as a range with a specific degree of certainty, and the three most common degrees of certainty and their corresponding z-values called critical values are given. So in this chart, go ahead and fill it out. 90% has a z-value of 1.645. So if you actually look up 0.90 on our table from our previous lessons, you'll get the number 1.645. We also have 95 has a z-value of 1.960, and a 99% certainty has a z-score of 2.576. Let's just I'll use the highlighter going over here. This is those values. We're going to use those. Okay. the confidence interval for a sample mean is, x bar is equal to x bar plus e. And you might be asking, what is e? Well, e is the maximum error of the estimate between the population parameter and its actual value. The maximum error of the estimate is also called the margin of error. Margin of error, let's write that. It's equal to the margin of error. And we basically have this formula for the margin of error. E, which is the margin of error or maximum error, is equal to z, which is a z value from over here, times s over the square root of n. What do these all mean? So this is your z value, and it comes from your confidence level. So if I said you have a confidence level of 99%, then you would use 2.576. S represents the standard deviation of a sample. So sample standard deviation. And the n is the sample size. Like how many people, how many pieces of candy. And what we're doing here is you might want to check for something called these conditions. N is greater than or equal to 30. You want to make sure that you're getting one larger than 30. All right, let's move on to our example about chess, which I'm the chess club advisor. All right, let's go over this chess problem. Chess, a poll of 315 randomly selected members of an online chess club showed that they spend an average of 4.6 hours a week playing chess. With a standard deviation of 1.2 hours, use a 90% confidence interval to find the maximum error of the estimate for the time spent playing chess. All right, the first thing I'm going to do is just take all the variables that we just read. So I have 315, so I think that is the total number of people there. And then it tells me it takes an average of 4.6 hours. So I would read that as the mean. Not sure if we're going to need that, but I'm just highlighting it. And then I have the standard deviation here, so s equals 1.2 hours. And then this confidence interval, we're going to have to go back and use the chart on the previous page to find the maximum error. And then this one right here, maximum error of the estimate, that is just the E. What is E? So I broke this down into some steps. Step number 1, find the Z value. So with a 90% confidence interval, we're going to have to use the z-score of 1.645. So a 90% is equal to z equals 1.645. Okay, so let's go ahead and box that. And then let's get our formula from the previous one. Find the maximum error of estimate. Well, that's just E, and you might just want to use the previous formula. Well, you can do my favorite, magic. Look at that. Just have to do a little bit of erasing there. Okay. Okay, so the z-score comes from here. So right there, I'm going to write 1.645. And then the s is the standard deviation. So that's why I'm going to write 1.2. And then the n value was 315. And if you didn't know, in your fractions, how do you make 1.645 a fraction? And you basically put it over 1. And that's why I'm drawing that fraction line. It's really 1.645 times 1.2 divided by the square root of 315. Let me go ahead and take a screenshot with my phone. Okay, let's go ahead and put that in our calculator. Press clear, and then I'm going to type in 2 sets of parentheses. And the reason I'm doing that is to show that we're in the numerator. I didn't have to put a multiplication sign, remember, because when they're next to each other and there's no plus or minus, then it's multiplication. And I'm going to divide that by the square root. Okay, so square root is in there, in the corner there above the 7, and it's an orange, so I'm going to have to press second x squared. Second x squared. And then, you see how mine's red? You're going to have to press the right key to get out, and then close your parentheses, okay? And this would give me a margin of error of 0.12. Sorry, 0.11. And then we can write a sentence to kind of help us understand what is happening here. We can say with 90% confidence, can't spell confidence confidently, confidence, that the mean time a chess club member plays per week within 0.11, that's from when we got above, hours of the sample mean time. Okay, let's put it in context and then you can try a problem. So basically, people that we interview for the chess club are playing 4.6 hours a week, right? We interviewed 315 people, and although there's a standard deviation of 1.2 hours, I am 90% confident that people are playing, and then my margin of error, the maximum error of this estimate is only 0.11. Okay, let's go down here. Go ahead, and it says in questions 1, 2, and 3, skip one problem below. So go ahead and let's just say you want to skip number 2, just put a big X through it, and you have more space to do questions 1 and 3. And then when you're ready, you can just press play to check your answer, or you can do it step by step with me as I go through all of the problems, but you only need to do 2. Okay, let's go over these problems here. Homework. A poll of 225 selected high school students. So again, I'm going to start annotating or marking up the text. I have n equals 225. High school students show that they spend an average of 2.75 hours per night doing homework with a standard deviation. So I have S for standard deviation, 1.5 hours. I have a 90% confidence interval to find the maximum error of the estimate for the time spent doing homework. Remember, the maximum error of the estimate is just E. We can do what we did above in those 2 steps. So the first step, step 1, is what's our z-score? Well, the 90% confidence interval is a z-score of 1.645. 1.645. Okay, step 2 is really what is our E value. And remember, E equals Z times the S divided by the square root of N. So let's just go ahead and some people say plug and chug. well, it's really substitute and evaluate. So our E value is equal to my z-score was here. Let's go ahead and write that in. 1.645 times our S value. Our S value was 1.5. So I'm going to put that there. And then my N value was up here, 225. Now, don't forget to write that one in what? The square root. What did I just say? Short-term memory, 225. Okay, let's go ahead and put that in our calculator. Now, here's a trick. This problem looks very similar to the one we just did. So I can repeat everything. To do that, I'm going to press second enter. Second, the orange button, and then the bottom right. And what it does is the orange word says entry. You're basically repeating the entry or copy and pasting. Second, enter there. We already had a 90% confidence interval that had a z-score of 1.645, so I don't have to change that one. This one was 1.5, and I believe this was 225. Go out and just press enter. And our answer is 0.1645. Now, it doesn't tell us how to round, but in the previous problem, we rounded to the nearest hundredth, so I'll just do, say, 0.16. E equals 0.16. And this sentence helps you understand what is happening. So let's just copy that sentence. We can say, with 90% confidence, the mean time a student does homework per week, I'm abbreviating, go faster, within 0.16 hours of the sample mean time. Guess we could just copy and paste that, but the big idea is that we're getting, because you're drawing the data from these random students, we have 90% confidence, pretty confident that, you know, when we draw a sample from them, they're only 0.16 hours away from everyone else. All right, let's try number 2. Number 2 here is telling us athletes, a pool of 350 randomly selected athletes, so there's my N value, 350, show that they spend an average of 10.25 hours a week. So the mean here, the average, I don't need. Let me say that again. The average we don't need for our to find our maximum error of estimate. But I'm still highlighting the numbers are given us. S equals 2.3 and a 95% confidence interval find the maximum error. Remember, the maximum error of estimate is just your E. We're trying to find E. So the first thing we're going to do is, what's our z-score? And this time, a 95% confidence interval basically tells us that Z is 1.960. 1.960. And to find our margin of error, our maximum, I know we're saying maximum error of estimate, that's just E equals Z times S over the square root of N. And so my Z is 1.96 times, remember that you're making a Z a fraction, so it's just Z times S. So my S value is 2.3 And the n value is up here at 350. So that goes inside 2.3 and 350. So again, the shortcut, second enter, you can just repeat what you had. And I have to change the z-score. 960, you can just type over it. And then our standard deviation was 2.3, and we had how many people do we have? 350. Press right, and I get 0.24. E equals 0.24, and then I can just use some magic. I don't want to get in the way of that one. And watch this. Let's see if we can do something. Boop. Oh, change it to green. Nice. Okay, now we can just erase the parts that we were saying. We have a 95% confidence that the meantime a athlete what are they doing? Practices per week within, what was our number? 0.24. 0.24 hours of the sample mean time. And our last one, of course, pets. Pets, a poll of 470 selected pet owners, so n equals 470, show that they have an average of 1.9 pets per household within a standard deviation of 0.5 pets. So again, we don't need that, but I'm just going to write x bar equals 1.9. And then a standard deviation of s equals 0.5. Okay, we have a 99% confidence interval to find the maximum error of the estimate. Okay, so the maximum error is the capital E. So just like the practice problem above, the first thing we're going to find is the Z. So a 99% confidence interval gives me that Z is equal to, just go back up to this chart, and 2.576. 2.576. Okay, the second thing is I want to get E, which is the maximum error of the estimate, or the margin of error. So I have E equals the Z times the standard deviation over the square root of n. And we were saying that to make Z a fraction is just over 1. So it's just really Z times S over the square root of n. Okay, let's do this color coding here to help you. Our Z score comes from right here. So let's write that in. E equals 2.576. Okay, and then our S value is our standard deviation. So standard deviation 0.5. And really that's just over our N value, which is 470. Okay, let's go over here. Let's just do this the first time, and I do two sets of parentheses to kind of show the fraction. I'm going to try something. This student told me a long time ago. So alpha y equals. Alpha y equals. You'll see this says fraction in green there, so let's just try it. Oh. Let's try it. Ooh, do you see what it did? It made a fraction for me. So again, that was alpha y equals. Alpha y equals. Good job, student of the past. Okay. So our Z score is 2.576, 2.5576, parentheses, and then our standard deviation in our problem is 0.5. Now to go downstairs, you just press down, and we're gonna have to get the square root button. So that would be second x squared, and then that would be 470. Now it has a red on the screen, so just click out to the right, and you press right again. So I'm out there, and just press enter, and I get 0.06. 0.06. Let's do some magic over here. Magic. What color do you guys like? Let's do black. Boom. We can say with 99% confidence, the mean time, what are we talking about? I mean mean time. The mean, whoops. The mean number of pets per, not week, household with what was our number? 0.06 0.06 pets of the sample mean number of pets. Number of pets. Okay, so that is using 8 point blah blah blah. What number is this? 8.51. Find the maximum error of the estimate.
Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.